Hey, Matt Mathersum here with Math Madness. On this show, we will use a little bit of madness and a little bit of mayhem to teach you some fundamental math principles. It's all about making math fun. Well, let's start with answering last week's Brain Twizzlers. Oh goodness. Well, the first thing is stay out of the Brain Twizzlers path, I guess. Well, we looked at the late, great Albert Einstein's famous equation, E equals mc squared. Well, the original formula he used before he switched it up was our question, right? Well, pre-1912, the original formula was this, M equals LC squared. What do we take away from this? Simple. If Einstein can change his mind, so can the rest of us, right? Well, moving on, there's one more thing I need to address from the last week's chat. Now, if you recall, we had a scenario where our restaurant, Big Daddy's Burgers, was open 24 hours a day, 7 days a week, right? We had a situation where our labor costs were $50 per hour, and we were only making $36.10 per hour. Again, we used the low numbers to keep the math very simple. However, I want you to think about this. There's only a $13.90 per hour deficit. That said, look how quick this can become a tsunami of mathematical madness. We said that we are open 24 hours, 7 days a week, so let's start there. It's one day, right? Let's take our difference of $13.90 and multiply that by 24 hours, which is in a day, right? Well, this gives us a total loss of $333.60 per day. Now let's compound that problem by multiplying the $333.60 by how many days in a year? Right, 365. That gives us a loss of $121,764. That's quite a lot, just from a $13 an hour deficiency, right? The point I'm trying to illustrate here is it doesn't take $1 million lawsuit to wipe you out. As you can plainly see, a $13 per hour deficiency can close your doors just as good as a catastrophic event. You can even use this as an example of pricing your menu. Think about if you just mispriced 13 menu items by just $1. We already saw how this can play out with our earlier scenario. It's actually worse in this case because here, the more you sell, the more money you lose. And our thing is, we don't ever want to leave any profit on the table, right? So speaking of profit, let's discover how your restaurant is going to achieve profitability here at the Forum Shops. Let's start with the first thing you actually are selling, and that, my friends, is time. And just as in our quotidian life, time here isn't your friend either. In fact, you're always up against it, and it's desperate to win. So now that we know that our product is time, and in our case, it's all wrapped up into some bodacious burgers, let's talk turkey. Well, one thing we know for sure is we have to sell these burgers for more than it cost us to make, or there will be no business. Better believe that, buddy. All right, moving along. Let's talk about cost. You can't make all this money without incurring some cantankerous cost. Now, if you're thinking about food cost and labor cost, then you're spot on. Together, these are called what? Well, they're called prime cost. So let's start with the juicy stuff first, your COGS, C-O-G-S. It's called cost of goods. This, as you might expect, is your food cost. These, by the way, are direct expenses that are used to make your dishes, such as ingredients. And just so we're clear, these types of expenses are variable cost. Now, I'm sure you're biting your nails in great anticipation for the formidable formula for this metric, so here it is. Got it on the back here, so I can surprise you all with it. And on our left-hand side here, we've got beginning inventory, purchases during that period, and ending inventory. All right. So once we find out what our cost of goods is, this tells you what you paid for your product over a certain period, okay? It could be a week, 2 weeks, or a month. But no matter when you calculate this, you must have reliable infrastructure to manage your inventory, and you want to do a physical count as well, okay? So now that we've got our formula, as I said, for our beginning inventory, purchases, and ending inventory, you can see our situation here. We've got $30,000 for the particular period for our cost of goods. We've got $20,000 at the beginning in inventory. Our purchases during that period was $15,000, and our ending inventory was $5K. Real simple to calculate, just simple addition and subtraction, right? But you got to know these numbers. Okay, well, Big Daddy, now if you remember from a previous example we used, we said our monthly sales were $150,000. Using these two figures, what is our food cost percent? How do we calculate this? What do you recommend? Why don't we take our COGS, which we just calculated here as $30,000, and divide that by our sales, which we said was $150,000. We get 20%, don't we? Just take the $30,000 over here and divide that by our $150,000 in sales. That gives us 20%. Okay, well, now we need to look at something else, right? Let's look into our labor cost, our direct labor cost. This is the other half that makes up our prime cost. So again, we're going to keep the math very simple here, for example. So let's look at this. Here we go. Let's say Big Daddy's Burger has the following labor cost here. Let me step over on this side. You can see we've got wages at $10,000. We've got salaries at $5,000. Our benefits equals $2,000. And our payroll tax is $1,000. So if we want to calculate our direct labor cost, all we do is add up all of these numbers, which I already have. That gives us a total of $18,000. Okay, well, this total of $18,000 plus our $30,000 that we talked about gives us a grand total of $48,000 in prime cost. Hold on one second again. Our $30,000 was for our food cost, right? That was our COGS. Our direct labor cost is $18,000. I added these up. We've got $48,000 in prime cost. Now, if we take our prime cost and if we divide that by our total sales, this is going to give us our prime cost percentage, which in our case is 32%. What did I do? I just took the $48,000 here, our prime cost. I divided that by our $150,000 total sales to get us the 32%. Is this good? Well, considering prime cost in this industry is around 60%, it's phenomenal. Way to go, Big Daddy's Burger.
Multiplying mayhem, multiplying mayhem, multiplying mayhem with Mayhem Matt. Yeah. And here's our host of Multiplying Mayhem, Mayhem Matt.
Well, thank you, Hope and Hummingbird Mimi, for that highly decorous introduction. It is most appreciated. And welcome to another exciting round of Multiplying Mayhem. I'm your host, Mayhem Matt. Let's get started. Well, today's topic is on three-term linear equation. I know, stay in your seat, it's going to get even better. So we're going to talk about how to solve for that pesky variable, combining like terms, using the appropriate operations, and much, much more. So let's get ready to meet our very first contestant right here. We've got 3y minus 11 equals 19. What are we solving for, ladies and germs? Well, we're solving for y, are we not? I don't know why. Don't ask me. Someone just said, let's solve for y. We're going to solve for y. Well, how are we going to solve for y? Well, we see that negative 11 is an impediment, is it not? We're isolating y. We want to solve for y. We just said we did. So how do we get rid of the 11? Well, I'm going to move the 11 over here to the right-hand side, don't I? Why? Because we're solving for y. Let's do that right now. Well, if I add 11 over here, what does that do? Gets them gone, does it not? Absolutely. 19 plus 11. Now, we're cooking with something, aren't we? Let's go ahead and solve that real quick, too, while we're at it. What does 19 plus 11 give us? Fingers and toes, calculators, whatever. Absolutely, it gives us 30. I love 30. You don't want to turn 30, though, because that's not that much fun. That notwithstanding, though, we've got 3y over here, don't we? So we're saying 3y equals 30. What we're really saying, though, is 3 times something gives us 30, right? Well, we know what the answer is, but let's pretend that we don't so we can solve this appropriately, right? So the y is being multiplied by the 3. What do we want to do? I know, you know, we all know. Inverse operations. Matt, when is it not inverse operations? It's always inverse operations. So let's inverse this operation. We got rid of the 3's over here. I divided 3y by 3, leaving us with, that's right, what we're solving for, y. Now we've got 30. I need to divide 30 by, that's right, if I did 3 on the left-hand side, I've got to do it on the right-hand side. 30 divided by 3 gives us, fingers and toes again, absolutely, 10. Does y equal 10? Well, you can figure that out for yourself. 3 times 10 gives us 30. Let's move on to this bad boy over here. But first, I know what you're probably thinking. Matt, we've got the variable on the right-hand side. Holy smokes, what are we going to do? Well, we're going to get our U-Haul, and we're just going to haul it back over here to the right-hand side. Watch how we can do this if you are a left-hand variable fan. Left-hand variable? Yeah, you know what I'm trying to say anyway. Well, let's say the 14 minus the 9z, we are solving for z, is equal to 41. Is this the same as that? It absolutely is. Think the symmetric properties of equations. We can do this. Algebra, it's a wonderful thing. Let's get started here and solve this beast real quick. We're solving for zebra. Let's move. How about this 14? It's a positive. I want to get it out of there. What do? Let's subtract that bad boy. Let's get rid of 14. It's got a hot date or something, so it's out of here. It's 41 minus 14 over here, though. Now, things are starting to shape up, aren't they? We've got a negative 9 zebra over here, and that is equal to 41 minus 14. Well, what's 41 minus 14? That's right, it is the big 27. But you don't want to be a member of the 27 club. You can Google that later. Let's see what we've got here. Now we've got negative z equals 27. Well, we're trying to solve for z. We've said that about 1,000 times, but it's still nonetheless very true. Well, z is being multiplied by negative 9, or what are we going to do? Inverse operations to the rescue again. Let's do it real quick, ladies and germs. We got negative 9 divided by negative 9. That isolates that z, which is what we were initially trying to do in the very first place. If I divide the left-hand side by negative 9, you know where I'm headed. I got to divide the negative 9 on the right-hand side as well. Getting rid of the 27 club. What are we left with? 27 divided by 9 means, yes, indeedy, negative 3. Is z equal negative 3 our answer? Man, I hope so, because we've got one more to do before I've got to get out of here. So let me flip over the Bertha board right here. And what are we left? Uh-oh. Well, what's this? We've got two term variables here. Holy smikes. What are we going to do with x over here and x over here? Well, let's think about this really quick. I see I got a 3x here that I could possibly move over here to the left-hand side to what? Combine that catastrophe. Let's combine catastrophes, right? 3 over here. Let's get rid of that. And we've got the negative 3x over here. And 5x minus 3x gives us a whopping 2x. It certainly does. Let's just go ahead and bring down our negative 4. And this mess over here is just equal to plus 8, is it not? Well, we're almost done. How about this negative 4 and positive 8? Is that more catastrophe that can be combined together? I think it is. So let's get rid of the 4. How do we do that? Well, it's a negative over here. And what do we want to do? We want to hook it up with hot daddy over here, number 8. So let's add it to get it gone from the left-hand side. But I'm moving it over here to the right-hand side. And that's going to give us a positive 12. It definitely is a positive 12. Not a bad age if memory serves. Anyway, we're left with 2x over here. And what is this looking like? Oh, Matt, we've seen this before, haven't we? We most certainly have. We see that x is being multiplied by the 2. We know we're isolating x, so we can solve for x, so we can get x out of our life. Well, let's do that. Divide 2 on both sides. Gives us the x over here. We've isolated for it. You know where I'm headed. If I do it on the left-hand side, what do I got to do? Got to do it on the right-hand side. Let's do it on the right-hand side. 12 divided by 2 gives us wait for it, positive 6. Is x equal 6 our answer? Man, I hope so. I feel like it could be. But anyway, that's all the time we have for here on Multiplying Mayhem. I'm your host, Mayhem Matt. We'll see you next time. Welcome back to Math Madness. So let's do our quick review. We know we have two main expenses for a restaurant, which are called prime cost. That's a combination of food cost and direct labor cost. We know how to calculate our cost of goods sold. We take our beginning inventory plus our purchases for that period, and then we subtract our ending inventory. We know that if we take our COGS and if we divide that by our sales, this will give us our food cost percentage. We know that direct labor costs are made up of wages, salaries, benefits, and taxes. Once we add all these together, this gives us our direct labor cost. We also know that if we add the direct labor cost and food cost together, this gives us our total prime cost. Whenever we divide that by our total sales, we get a prime cost percentage. Okay, that's all the time we have for today. But here's this week's brain twizzler that I know you've all been waiting for. I don't know when I'm ever going to learn to stand out of the way of that. All righty, though. So let's look at our brain twizzler this week, which is going to be, who was the very first food chain here in the United States? Who was the first fast food chain here in the U.S.? Well, thank you so much for joining us here on Math Madness. I'm your host, Matt Mathersum. We'll see you next time.